Okay, guys, so this is the set covering assignment, which is not really an assignment. And so this is a novelty in this session. And the key idea here, what we are trying to do is to have an assignment, a kind of a fake assignment, where people can submit their solutions and can share code, okay? So you can't share code, you can share IDs, but not code on the other assignment. But here what we wanted to do is make sure that you guys can actually share code and show code on a particular assignment so that people can say, oh, this is really how you do a local search. Oh, this is how you can do a constraint programming solver and so on, okay? Sometimes, it's like in programming, looking at the code of somebody else can actually help you thinking about, how you can actually implement something yourself. And this is what we are trying to achieve here, okay? So I'm going to describe the set covering assignment, and then I'm going to talk about some of the ways you can share that later on in this video, okay? Now, set covering itself is a very interesting problem that pops up everywhere, okay? I'm going to use one real-life example here, but there are many, many other examples, and this actually is a problem that pops in a lot of other, actually real application, either as on its own, but generally as a subpart of more complex algorithm. Okay, so this is an example using fire stations that have to cover a region. So what you see here is a big geographic region, okay? And every one of the big dot there, the black dot, is a location where you can set up a fire station. And the key idea is that you have to cover all the small region there. They are numbered like 0, 1, and so on and so forth. You have to cover 80% of these things in 7 minutes, okay? And so what you get, that's requirement for emergency services. And so what you want to do is to select a subset of them such that you basically cover the entire region, at the minimum cost. Okay, this is, for instance, a particular solution. Okay, so you see here, this particular fire station is covering this part of the entire global region and these sub-regions over there. Okay, and so on and so forth. Okay, and so in this particular case, you have 6 selected fire stations that basically satisfy the legal requirements of the entire region. Okay, and you try to do that, of course, at the minimum cost. Okay, satisfying the legal requirement, getting to the people, in the time that is specified by law, but also at the minimum cost. So this is how we can model this thing more formally, okay? So in a sense, all the regions that you have seen in the particular, in the example that I've shown are going to be called item, okay? So we are basically given a number of items, n items, and we will have to cover these items, okay? How do we cover them? We cover them by set. That's why this is called set cover, okay? So in this particular case, the set of fire station, okay? And essentially a fire station is defined, or a set in the more abstract version, is defined by 2 things. It's cost. That's the cost it takes you to actually build it, okay? And then the items that it covers. When you have a fire station, you will know which of the regions you will cover in 7 minutes, 80% of which you can cover in 7 minutes, okay? And so, when we look at the abstract version of the problem, for every one of these sets, we know which item they cover. We get this SI, okay? This set SI, which tells you that set I is actually covering that many items, okay? And then, so this is the data. These 4 things there that I'm listing out is the data. And then the only decision variable that you need in this particular problem is find out if you select set I or not, okay? So xi is 1 if you select set I, think fire station. I'm selecting fire station I. And 0 otherwise, you don't select fire station I. Okay, and so now once you have this decision variable and this data, you can formulate the problem mathematically. Okay, and what you see there is that what you want to do is minimize a linear sum again, and this is the sum of the cost of opening every one of the fire station. So this is Ci, which is the cost of set I, times Xi, which is 0 if you don't open, if you don't select that set, or 1 if you select that set. Okay, so you basically have the cost of all the sets that you are selected, or all the fire station that you are building, if you want. Okay, and then you have 2 constraints. The first, well, actually 1 constraint. The one constraint that you have is that every one of the items has to be selected. How do you do that? Well, the sets they belong to. Okay, so you have to make sure that for every one of the item there is at least one set that it belongs to which is selected. So you basically make sure that the sum of the variable xi that cover that particular item is greater or equal to 1. An item can be covered by two different sets, and that's fine, but it has to be covered by at least one. And that's what this constraint is expressing. And of course, you build the entire fire station or not. So this is a binary 0-1 variable. Okay? So that's basically the formulation there. The input is a little bit more interesting. The only thing that you will have is essentially the number of items that you need to cover, and then the number of sets that can be used for covering them. And the rest of the data of the instance are really related to the sets. Okay? They're going to specify the cost of every one of the set, and then for every one of these sets, you will have a list of all the items that they cover. Okay? So essentially, every one of these lines here may have different number of elements because essentially that they represent for every set what are the items that are covered by that set. Okay? So in a sense, to summarize, you have the number of items, you have the number of sets, you have one line per set, you have the cost of the set, and then the list of the items that are covered by that set. Okay? The output is very simple. Once again, objective function, whether it's optimal or not, and then which of these sets have been selected. That's the decision variable. That's the values that we want to see. Okay? So it's a 0-1 variable for every one of these sets. Okay? This is an example of an instance. You see the number of items, you see the number of sets, 5 and 4, okay? So you obviously have 4 lines since you have 4 items, okay? The first one is telling you that this is a cost of 12, and then that particular set is covering item 0 and item 2, okay? And so you can see that item 0 is only covered by that set, so we know for sure that that particular set will have to be selected. Okay? This is an example of a solution. Okay? So it's a cost of 24. It's not optimal. It's not proved optimal. Okay? So what you see there is that we select set 0, set 1. We don't select set 2, but we select set 3. Okay? So that's essentially the output, very simple output. Which sets are you selecting? Okay? So as I said, the key point about this assignment is not a real assignment. It's something which is open source. You can share your code. Okay? So we give you some code, some simple greedy solver, some constraint programming solver. You can look at that code and you can get inspired by it. Okay? It also shows you how you can code an external tool. Okay? So go and look at this. Okay? So this will give you a sense of how these kinds of solvers are organized. And it can give you some inspiration when you actually build your own. Okay? So you start from something and you can actually see how it works on this particular example. Okay? Now you can design your own code and then share it with some of your friends. Okay? So you can use GitHub for discrete optimization and share your code with your colleagues. If you get a better local search, a better constraint programming solver, a better mathematical programming, a model for actually solving this problem, just share it. Okay? You can do this, and your colleagues, your classmates can actually look at this and get inspired by it. Okay, so once again, the goal here is to share information such that people can get started. People who don't have experience in optimization can look at some code and know how to actually build some more complex solvers. Okay, don't list results. We don't care about the results here. This is really about sharing the code. Okay, so having a lookup table, is the most boring algorithm ever. Okay, now you can submit any solution as well inside, on all the instances in the data set. That's also good. Okay, such that different algorithms can be compared, and then people can say, "Oh, this algorithm is really cute. I want to see how well it does. What is the code doing that?" Right? So you can do that, and you can view, the leaders on as well, like in any other assignment. So have fun. This is an assignment that you can share with other people, where you can discuss the various techniques, where you can go into the detail of the code. So this is something that was recommended to us last year, and I think it can make a difference for people who are really starting in discrete optimization and want to look at various code before they start their own. Okay? Have fun, guys. This is a very simple assignment, no pressure at all. So you can see code, you can share code. So this is an interesting novelty in this particular session. Okay? Have fun, guys. See you.